This lesson is for FST, lesson 11.5 on using the central limit theorem to find probabilities. There's nothing really very new in this lesson, it's just taking some of the ideas that we've learned in the chapter and putting them together. Let's quickly review the central limit theorem. Remember that if the original population is said to be normal, or if the sample size is 30 or greater, then you know that the means of the sample size will be equal to the mean of the original population, and that the standard deviation of the sample will be calculated by doing the original standard deviation divided by the square root of the sample size, or n. So let's just try to put those pieces of information into practice along with some of our earlier skills from Chapter 11. In a certain country, the mean family income, when converted to US dollars, is known to be $13,500 with a standard deviation of $2,000. Suppose a random sample of 100 families is chosen. Let X bar be the mean family income of that sample. Determine each of the following: the mean of the sample and the standard deviation of the sample means. Does the original say that the income is normal? It does not, but we do have a sample size 30 or greater, so we can go ahead and do part A. The mean is going to be the same as the mean of the original population. So the mean of the sample, which is what we're looking for, is the same as the original mean. So we would just find that number and copy it down. It also asks us for the standard deviation of the sample. The standard deviation of the sample, remember, is the original standard deviation divided by the square root of the sample size. So this one we don't need a calculator to determine. 2,000 divided by the square root of 100 is going to be 2,000 divided by 10, so cut off a 0 on both of those, so the standard deviation sample will be 200. So that's nothing new, that's a review from the central limit theorem from lesson 10.4. Now let's move on to part B. Find the probability that the sample mean is less than 13,000. 13,000 is a piece of data that we need to convert to a z-score. So we're going to subtract it from the mean, and we're going to divide by the standard deviation. Now be careful here, are we doing it for the sample or for the original? And it says sample here, so we want to use this standard deviation, the standard deviation of the sample, not the standard deviation of the original population. So we are going to divide by 200 here instead of 2,000. Be careful here when you type it in, you want to make sure to do the top number divided by the bottom. So you want to make sure to do your subtraction first, almost even as a separate step, because if you type it in as is, your calculator will divide these two numbers and then subtract. And you don't want it to do that. You want it to subtract and then divide. So either put the top in parentheses and do it all in one command, or subtract first, hit enter, and then do the division as a separate step. So when you divide here, you should get about negative 2.5. Now we're not done yet. This is simply the z-score. So now you have the option to look up 2.5 in a standard normal curve in one of those charts. You'd look up positive 2.5 and you'd be getting a number for this area here, everything to the left. And when you do that, you'd get 0.9938. Remember that we're trying to find numbers less than 13,000 or less than negative 2.5 once it's been standardized. So let's draw actually what we're trying to find. We're trying to find from negative 2.5 and left. So know that this tail is the same size as the tail here. So if we do 1 minus 0.9938, that'll be the size of the tail and the number's less than negative 2.5. And so when you do that, you get about 0.0062. If you had your graphing calculator available and you wanted to do it that way, you would just type in normal CDF. The lower bound would be negative infinity, the upper bound would be the z-score that you got. You'd still use 0 for the mean and 1 for the standard deviation, and you'd end up with the same answer here. Moving on to part C. Part C is exactly the same as part B, you just have more work to do. So again, we're still using sample size, and now we're trying to find between 13,300 and 13,700. So let's calculate both of those as z-scores. And so very quickly here you'll find that you get -1 and +1 for those two calculations. Probably wouldn't even need a calculator for those. And if you remember correctly, going all the way back to lesson 11.1, if we're looking at numbers in between -1 and 1 standard deviation, we know that that stretch or that probability or the space under the curve between those two numbers is 68%. And I would be okay with you leaving your answer like that, even though it's not exactly perfectly correct. It's what we learned back in 11.1, and I'm perfectly fine with students leaving it that way. You could also do it on the calculator, using again the normal CDF command, lower bound of 1, upper bound of, lower bound of -1, upper bound of 1, mean of 0, standard deviation of 1. And it would give you 0.6826, I believe. And so obviously it's a little above 68%, but either one of those answers is perfectly fine. If you were using the table to figure this out, you'd look up +1 in the table. And if you look that up in the table, you'd get 0.8413. We would also need to find the complement of that, so we would do 1 minus 0.8413. And the tail at the bottom would need to be cut off. So once you do the complement, you get 0.1587. You would need to take the original space from 1 back, 0.8413, and take away the tail, which is on the left here, which we don't need. So we found the tail and we took that away from the number we were looking for, and again you'd get 0.6826.